Hello, welcome to my channel. This is Obro, and in the last class we were continuing with the three-phase induction motor. So I'm going to continue with the numerical which I left in the last video. So we were discussing about the rotor input is equal to rotor copper loss divided by slip. So rotor copper loss, we know the value 329, that is divided by slip. So if we can divide these values, so we have to just use the calculator to divide this value. So we will get the value as that is 658, 658, and this is 6589 watt. So we have understood how to calculate. So what is the next part we will do? Next part we are going to do, that is the rotor copper loss. Rotor copper loss at 5% slip. So rotor copper loss at 5% slip. So we know that copper loss is equal to 3 I2 square R2. So we'll get the value of what is the I2 and what is the R2. So here we'll just put the value. We have already taken the value of I2, that is 33.14 into 33.14 square into R2. R2 is the resistance, that is 0.1. So if we just calculate the values, 3 into 33.14 whole square into 0.1. So if we can calculate the value, it will come as 329 watt. So now we will go to the next part of the questions. That is the speed at the maximum torque. So what is the speed at the maximum torque? So we will find out that that part. So that is the speed at the maximum torque. That is the speed at maximum torque, that is equal to 1 minus 1 by S into 120 F by P. So S is equal to R2 by X2. So what is R2? R2 is equal to 0.1, that is 0.1, and what is X2 reactance, that is 0.9. So slip is equal to 1 by 9. So now we'll put the value here, 1 minus 1 by 9 into 120. What is the frequency here? We have already made the frequency. Frequency is equal to 50 hertz, and that is 4 pole. So if we can calculate this, that is 1 minus 9, 8 by 9, 8 by 9 into 1500. So if we can calculate this value, 8 by 9 per 00, that is 1333 RPM. So this is the answer. So I hope you have understood how we have calculated the maximum torque. This is the formula. S is equal to 1 minus S into 120 F by P. So S is equal to nothing but resistance by reactance. So we have put the value as 1 by 9. So now we have put the value and got the speed at the maximum torque. So now I'm going to proceed with the next question. So I hope it is very easy for you now. Now I'm going to the next question. That is a 6-pole 3-phase induction motor. 6-pole 3-phase induction motor is the question. As 6-pole 3-phase induction motor, 6-pole 3-phase induction motor runs at a speed of 960 RPM, and the shaft torque is and the shaft torque is 135 0.7 Nt. So what we have to calculate? Calculate the rotor copper loss. The rotor copper loss if the friction and windage, if the friction and windage loss amounts to 150 watt. The supply frequency is 50 hertz. So I hope you have understood the question, what it wanted to mean. There is a 6-pole 3-phase induction motor. It runs at a speed of 960 rpm. Shaft torque is given as 135.7 Nm, and we have to calculate the rotor copper loss if the friction and windage loss amounts to 150 watt and the supply frequency is 50 hertz. So we have to give the given. What are the given here? P is equal to 6-pole and NR is equal to speed is 960 rpm. Windage and friction loss, that is given as 150 watt. Frequency is equal to 50 hertz. So here we have to calculate. We know that what are the things we need to calculate here. So first of all, we will calculate the synchronous speed ns. Ns is equal to 120 F by P. So 120, what is the frequency over here? Frequency is 50 hertz. 50 divided by pole. Pole is 6. So we can calculate 20, that is 1000 rpm. So we have found the value of ns. Now we have to find the value of slip. So slip is equal to nothing but ns minus nr by ns. So we have already found the ns, synchronous speed, that is 1000 rpm. And what is the value of nr? Nr is already given 960 rpm. 960 divided by, again we are dividing by 1000. So if we can calculate, that is 40 divided by 1000, that is 0.04. Slip is 0.04. So we have found the synchronous speed, we have found the slip. So what we have to do now next, that is the power output. What is the power output? Power output formula is 2 pi NTS divided by 60. So we have to put the value. 2 pi is 3.14, n is the speed, n is the 960, and here we have also already got ts. Ts value is the shaft torque, that is 135.7 into 135.7 divided by 60. So if we just calculate the whole value, if we just calculate, so we will get a value as 13630 watt. So this is the power output. So what is the gross output? Gross rotor output. Gross rotor output. So what is the gross rotor output? Gross rotor output is equal to, we can put here as the output power plus losses. Output power plus losses. So what is the output power? We have just calculated as 13630 watt, and we know already the loss. What is the loss? Windage and friction loss, that is given here as 150 watt. So if we can calculate here, so it is 13780 watt. So I hope you have understood. 13780, that is the watt. Now what we have to find out? We have to find out the rotor copper loss. So we have to just erase this part. So what is the rotor copper loss? Rotor copper loss is equal to gross output power. Rotor copper loss is equal to gross output power, into S divided by 1 minus S. So here gross output power is already out, that is 13780 watt, and sleep is equal to 0.04 divided by 1 minus 0.04. So if we can calculate this value, so we will get as 574 watt. So I hope you have understood how we have calculated this value. So it is also very easy question. So I hope you have understood how we have calculated the sleep, and that is the synchronous speed, sleep, output power, and the gross output, rotor output, and we have finally calculated the rotor copper loss, that is the gross output power into sleep divided by 1 minus sleep. So we have put the values and we have finally got the answer. So I hope you have understood this, and we'll be continuing the next part of the videos in the next class. Thank you.